Okay, part 3 for rational expressions is going to cover adding and subtracting rational expressions. Here is where we are going to need to find common denominators. So to be able to add or subtract rational expressions, just like fractions, we need a common denominator between the two rational expressions. In other words, they need to be the exact same. Okay, so here's overall the steps. So step number 1, factoring the denominators is not always required. So that's just if necessary. Step 2 is always necessary. And step 3 is how we, finally actually do the addition or subtraction. Okay, so this part right here, find the common denominator, this is the tricky part, and I'm kind of glossing over that. So if we look at the example I have there, you can see that they are in part the same. They share an x. They share a factor of x. So in that case, we only need to multiply by unshared factors in the denominator. Okay, so it can be helpful to factor and identify what's shared. So both the rational expressions have a factor of x. The first rational expression, however, doesn't have this factor of 3. So we'll need to multiply the other rational expression, top and bottom, by 3. So remember that 3 over 3 is just equal to 1, so we can multiply anything we want to by 1. And the 2 over 3x does not have a factor of 2, so we're going to multiply both top and bottom by 2. Okay, so let's see what we end up with. In the numerator of the first one, 3 times 7, we get 21, over 3 times 2x, and that gives us 6x. And the other rational expression, 2 times 2, we get 4 in the numerator, and 3x times 2, we get 6x. So we ended up with what we wanted, the common denominator. So kind of our work on the denominator is done. It's 6x. And now we do step 3 in the list of steps up there, and we end up adding 21 plus 4, and we get 25. Another example, let's start by factoring denominators. First one, greatest common factor of 5, leaving an x plus 3. Second one, we've got difference of 2 squares. We'll have x plus 3, x minus 3. These share the factor of x plus 3. So that part is already common. We look at the factors that are not shared by the other rational expression. The first rational expression does not have the factor of x minus 3. We multiply top and bottom, numerator and denominator, by x minus 3. That's like multiplying by 1. And the second rational expression doesn't have the factor of 5, so we'll multiply top and bottom by 5. So we want to recognize that that 5 is going to be multiplied by that quantity x plus 2, so let's put parentheses around that. So on the next step, we make sure we distribute that 5. Okay, we now have our common denominator, 5 times x minus 3 times x plus 3. In the numerator, let's distribute that 2. Okay, x minus 3 is multiplied by 2, so we distribute that 2, and that gives us 2x minus 6. Okay, we've got our common denominator of 5 times x minus 3, x plus 3 for our other rational expression. And here we want to distribute that 5, getting 5x plus 10. Now we do that last step where, because we have our common denominator, we can add across the numerator. So we can add 2x and 5x, we get 7x, add negative 6 and 10 to get a plus 4. Here we have another example. So we try to factor the denominators and see that there's nothing to factor, and the denominators do not share any factors. They're totally different. So this first one, we're going to need to multiply by the denominator in the second one, top and bottom, a minus 3 over a minus 3. And keep in mind that we're multiplying that a minus 3 times the entire quantity, a minus 1 in the numerator and a plus 1 in the denominator. The other rational expression we're going to multiply by the denominator of the first one, so a plus 1 over a plus 1. And again, we're multiplying the entire quantities. So we have our common denominator now, a minus 3 times a plus 1. No need to multiply that out. We can keep that denominator in factored form. We do want to multiply out the numerator so that we can combine like terms across the numerator. So we've got two linear binomials. We can use FOIL, a squared, and then it's going to be a minus 4a plus 3 for the first expression. Second expression, all right, we got our common denominator. And multiplying out those two factors, we get a squared minus a minus 2. Now we add across the numerator. And that denominator is that common denominator that we found. So we have a squared plus a squared, so 2a squared, negative 4a minus a, so minus 5a, plus 3 minus 2, so we get a plus 1. Now let's look at subtracting rational expressions. We're going to find a common denominator again. So factoring that first denominator, we get x plus 5 times x minus 5. And so we have x plus 1 and then minus x minus 1 over factoring. We bring out the common factor of an x, and that's times x minus 5. So they share the factor of x minus 5, so we don't need to multiply at all by that. The first rational expression we're going to need to multiply by the unshared factor of x, so x over x, and remember that's going to be multiplied by that whole quantity, x plus 1. The second, we're going to multiply by x plus 5, top and bottom. All right, and then again, that x plus 5 is times that that x minus 1. Okay, so we've got our common denominator, x times x plus 5, x minus 5. And distributing that numerator, we get x squared plus x, and then minus, okay, we got common denominator, and multiplying out the x minus 1 times x plus 5, we get x squared plus 4x minus 5x. Okay, now is where we are going to subtract across the numerator. So start off with that common denominator that we came up with. And we want to apply this negative to each of the terms as we subtract. Okay, so we have x squared here minus an x squared, so that's no x squared. And then we've got this x minus a 4x, so that's going to give us a negative 3x. And then we have no constant term in the first rational expression, but we have a minus negative 5, so that's going to end up being plus 5. Okay, let's look at this one. It looks like they don't have the same denominator, But let's do something to the denominator of the second rational expression. Let's factor out a negative 1. Okay, so let's factor out that negative 1 and figure out what we're left with. Okay, let's start with the negative x. If we factor out a negative 1, that's like dividing by a negative 1, we get a positive x. And if we divide 1 by negative 1, so we divide this 1 by negative 1, that's going to give us a negative 1. Okay, so we end up with having something that looks pretty common. Now remember, we can take that negative that is in the denominator and we can move that so that it's just in front of the whole thing and rewrite this as 2 over x minus 1 minus 3 over x minus 1. Okay, so we automatically, by factoring out that negative 1, get the common denominator. So common denominator is x minus 1, and we do that subtraction, 2 minus 3, we get negative 1.